Yeah, evidently we are having some technical difficulty and I can't be heard.
Jason, we hear you now.
Okay. We're going to try this again, folks. Thank you for your patience. So welcome, everybody. Thanks for joining us. I'm Jason Thomas, and I oversee business development for Skeleton Key. Skeleton Key is a platinum-level FileMaker Business Alliance company, an authorized FileMaker trainer, a member of the Apple Consultants Network, and a Microsoft registered partner. We're headquartered in St. Louis and have developers all over Missouri. Today, you've been staring at this slide for a few minutes, so you've probably read it 6 times and realized we're in the webinar number 10 in the 12 Days of FileMaker 12 series. We're going to cover the ExecutesSQL function, which is new to FileMaker and opens up the power of the SQL query language to any FileMaker calculation. Before we dive into that, though, we need to thank our hosts. The FileMaker Academy. Skeleton Key is proud to be a charter member of FileMaker Academy, which is a consortium of the leading FileMaker development companies in the U.S. All FileMaker Academy companies are platinum-level FileMaker Business Alliance members who represent the best of the best in FileMaker development. Our purpose is to further educate FileMaker users and developers, to encourage best practices, and to foster further adoption of the software. So as we get started, I want to cover a bit of housekeeping. Please type questions into the GoToMeeting question box. I can tell several of you found that as we were having audio troubles. Thank you. Continue as you have the questions. Raise your hand, type the questions into the box, and we'll cover those at the end. If we don't have time to cover all of the questions, we've got a lot of people on the line. We would love to, we'll respond with an email to each one of you, letting you know we've gotten your question and reaching out to answer it. If you don't, for some reason, hear from us, feel free to contact us at info@skeletonkey.com, and we'll respond to anyone we can that way. Please allow me to introduce today's speaker, Greg Lane. Greg is the Vice President of Application Development here at Skeleton Key. He's a FileMaker certified developer. He's a frequent presenter at FileMaker Developer Conference and has authored articles for the FileMaker Advisor magazine, contributed to books and white papers and other FileMaker-related publications. Greg will be speaking at the 2012 FileMaker Developers Conference, covering SQL Basics and FileMaker developers, or excuse me, SQL Basics for FileMaker developers. That's a pre-con session, so please come out early, a little early, and hear Greg talk about that. And without further ado, take it away, Greg.
Thanks, Jason, and thanks everyone for attending today. I've got a lot of great stuff to share with you. So let me tell you a little bit about what I'm going to talk about. Just a brief agenda. We've already been through an introduction, and then I'm going to dive right into describing what the ExecutesSQL function is, and talk about how you use it, and then some things that you can do with it, and give you a few resources to learn more. And toward the end, we'll take some questions, and I'll give answers. So let's dive right in. So the ExecutesSQL function is brand new in FileMaker 12, and just like any other calculation function, it's the function name is ExecutesSQL, and it has a series of parameters that we give to it. And so I've got lots of live examples I'm going to show you in a little bit, but I'm just going to do a few basics right here. So the first parameter is the SQL query, and that can be any select statement. If you're familiar with SQL, then you know that there are lots of types of SQL queries. The select is the most common, that allows you to get data from a data source. The ExecutesSQL query does not allow you to insert, update, or delete data, or do anything to alter the schema of your database. That this is really useful to allow us to get data from any context, from any location in FileMaker, regardless of the context. So we have access to every table that's available in the current database. So the other parameters used in the ExecutesSQL function are the field separator, the row separator, and then a series of optional arguments, and we'll get into more details on those in a bit. The result of this function is always text, and if there's any error in the SQL query, you're going to get a question mark as the result. So here's a simple example with the ExecutesSQL function, and the first parameter here is a select statement that is getting the city and account of records from the contacts table, and it's getting those where the state equals MO, and we're grouping those by city, and then we're only showing the groups that have a count that is greater than 2. And so then the second and third parameters that we're using here are the char9 function, which will give us a tab character, and then the third parameter is just a carriage return. So the result of this with my sample data are Kansas City with 4 contacts and St. Louis with 9 contacts. So you can see that just a little bit of SQL here gives us a kind of a sub-summary sort of report in a way that's can be very convenient. So there's lots of things that you can do with this. I'm going to show several examples as we get into this just a little further. So some places that you can use the ExecutesSQL function. There are lots of places to enter this in any calculation within FileMaker. So you can use it in calculation fields, auto-enter calculated values. You can use it in validations. Any script step that uses a calculation dialog, you can certainly use it there. You can use it for tooltips or conditional formatting. Even in custom menus, you can do the title or the condition on which to install. That custom menu can be specified with the ExecutesSQL function. You can certainly use it in the security calculations. 2 of my favorite ways to use the ExecutesSQL function are with web viewers and also with charts. So there's some really powerful things you can do there. Also with portal filters and script parameters can use the ExecutesSQL function, of course. And the data viewer is a great place to try things out and make sure that your query is working the way you expect it to. So let's look just a little closer at the parameters that are used here for the ExecutesSQL function, and then I'll dive into some demos. So the first parameter is just any valid select statement. The second one is the field separator, and this is going to be the value that is inserted between each of the fields from the result. And that can be 1 or more characters. By default, if you don't include a field separator, you can't leave it blank. But if you include just a pair of double quotes, you'll get a comma as the default field separator. Likewise with the row separator, if you leave that blank with a pair of empty quotes or an empty variable, for instance, you'll get a carriage return. But that can be 1 or more characters. You can insert as many characters as you want between the fields or the rows. The arguments are optional, and you can have from 0 to 997 values that are going to get inserted in place of a question mark as part of your SQL query. And that's really useful in a variety of situations because FileMaker will handle conversion of the data type for you, for instance, from a date or a time. And there are some nice things that you can do with by using these optional arguments as part of your query. You certainly don't have to use those. You can calculate the query just as you normally would in a calculation, but using the optional parameters there can be useful. So let's dive into some demos. I'm going to switch over to FileMaker. And so let me talk just a little bit about the structure of this file so that you'll understand what's going on. I've got 4 tables in this FileMaker file. The first table is where I've got a series of SQL queries that we're just using for demonstration. And then I've got 2 tables that really have data in them. One is a contacts table, and the other is a states table. The contacts table has about 1,000 records. The states table has 55 records. And it's important to note that there are no relationships between these tables. And when you use the ExecutesSQL function, your SQL query does not have access to related data unless you specifically create a join within your SQL query. So you have to be very specific about that, but anything that you have in your relationships graph, as far as relationships go, are not used by the SQL query. All right, and so let me show you in the SQL table how I've got that set up. I've got basically a text field for the query, and then text fields for a field separator and a row separator, and then a repeating field for parameters. And then the result that I'm using is simply an ExecutesSQL function, and I'm passing it those fields from the same record. So the query, the field separator, the row separator, and just 5 of the parameters. So what that gives us is I've got a layout that looks like this based on the SQL table. And so we can type an SQL query up here in this top field, and then we'll get the result down at the bottom. And so if the field separator is empty or blank and the row separator is blank, then we get the default comma between each of the fields. So this query, I'm sure there's some people out there who are not that familiar with SQL, and there are probably others who are experts with it. So I'm trying to address both audiences a little bit here. So bear with me on some of the fundamentals. But with this query, we're simply saying select every field. This asterisk is a wildcard that says give me every field from the contacts table. And so that's what we're getting here. If we change the field separator to a tab character, then we get the data spread out with a tab between each character. And likewise, if we put in a different row separator, like 2 carriage returns, then we get a blank line between each record. You can add parameters in here, but if you don't have a question mark as part of your query, then they're simply ignored. So let's look at another example. Here we have the same query, but we've added a where clause. And in this case, we are using the optional parameters. We've got 3 question marks. So we're saying where the ID is in this list of values. And for the list of values, we're passing in these parameters, 16, 15, and 14. If we change one of these parameters to 13, then we'll get a different set of records here that includes 13 as the ID. Here's another example with a different kind of field separator. So instead of just using a comma, we're actually using some HTML tags here. So we're starting the result for each row with some static text, an opening TR tag and an opening TD tag. And those are enclosed in single quotes, those text constants. And then the double pipe character is a concatenation character, kind of like the ampersand in FileMaker. And this allows us to take this static text, and then we're going to get the ID value. And then in between these fields, we're going to get the field separator, which is a closing TD tag and an opening TD tag. So we'll get that between each of the fields. And then at the end, we get a closing TD tag and a closing TR tag. The result of that is basically the table rows and table data from for an HTML table. And I've got an example a little later where we'll actually use something like this in a web viewer to display this information. Here's another example where we're getting just the first name from the contacts table. And we're using a function here to operate on one of the fields. So we're using the lower function, which converts the first name to lowercase. And then we're using a like operator. And like allows us to use a wildcard as part of our criteria. So essentially what this does is finds anyone with the first name that begins with the letter M, regardless of whether it's uppercase or lowercase. These comparisons are case sensitive. So if we, for instance, changed this to say first name like M %, we get no results because all of our first names happen to have a capital letter as the first letter. So it's important to understand that these functions are these comparisons, the operators, are case sensitive, which is a little different than we're typically used to with FileMaker. So we convert it to lowercase, and that helps us to work around that. There is no, in some SQL environments, you have a similar function to like called iLike, and that's a case-insensitive version of the like operator. FileMaker does not support that as far as I know. The next example here adds the distinct keyword, and essentially this allows us to get a summary of the distinct values from the city and state fields. So we're getting just the contact records where the state equals MO, and then we're only showing one line or one row result for each unique city and state. So that's what the distinct keyword does for us. Here's another example that is a little more complex, but you can kind of see a pattern developing here where the first thing we're selecting is the city, and that's this first column of data. And then the second thing we're showing is the count of the contacts in that city. And then this next part is actually calculating the percentage of the total contacts within the state of Florida that are represented in that city. So I'm going to share this file, and you're welcome to pick that calculation apart later. But you can see there are two parts to that. There's the numerator up here and another select query. These are called subqueries. That another subquery here as the denominator that are used to calculate that percentage. And then we're concatenating in the percent sign at the end of that. So we're getting that data from the contacts table where the state equals FL, and we're grouping those by city. Here's another example that just shows the use of another function. In this case, we've got a left function. So we're taking the left 4 characters of the word delicatessen, which gives us a result of deli. Now you'll see here that I'm using a utility table to select from rather than the context table or the states table. I'm using this utility table that just has one record in it. And that gives me a simple way to try out queries and get just a single result or a single row as part of the result. FileMaker also has a set of internal tables or meta tables that have information about the tables and fields in our database. And so those are the FileMaker Fields table and the FileMaker Tables table. So you don't see these appear in the list of tables in the database, but they're available in any FileMaker database. So we can query those and get some information about our tables and fields. And in this case, we're actually getting a list of the base table names from this file, and then the count of the fields for each of those tables. So it's a handy way to get some information about your database. And I've got an example later on. I may not show it today, but I've got an example that shows all of the information that you can get from FileMaker Fields and FileMaker Tables. The next example I've got is just a simple join, an inner join. And a join is essentially like a relationship in FileMaker. It allows us to take two tables and join them together based on some criteria. So let me just walk through this query with you. So we're selecting all the fields from the contacts table, and we're joining the contacts table to the states table on this condition where the states abbreviation, so the states table, and then the abbreviation field in the states table equals the contacts table state field. So where those are equal, we're going to get a match, and the result is going to show us the one row for every combination of contacts and states. So the result here is all of the contacts fields and then all of the fields from the states table appended at the end here. So it's important to note that if you have records in either the contacts table or the states table that do not have a match, the inner join keyword will cause those rows to not appear in the results. However, if you do want those values to appear, you can use a left join. So here's an example that does another join from states and a left join keyword there with contacts using the same kind of criteria, states abbreviation equals contact state. And then we're getting the states, the name of the state, and then a count of the contacts in that state. And so you'll see here that we have some examples where there are no contacts in that particular state. And so this is a way to do a report where, say you have a department or categories of products where you want to take some sales data, for instance, and show a report of how many of those units in each of those categories were sold over a period of time. But you want to make sure that every one of the categories is listed. This is a way that helps you to do that using a left join. The ExecutesSQL function does not support a right join, so your only option there is to reverse your tables and use a left join. There is also not a full join available. So here's another example that I'm simply using to show that you can get the result of a global field. And so I'm using my one record utility table, and it has a field in it called global that is a global field. It uses global storage for the field. Now, something else to note here is that this field name is enclosed in double quotes. And the reason I did that is that global is actually an SQL reserved word. And so anytime you have a field name or a table name that is a reserved word, you must enclose it in double quotes or you'll get an error. So if we take out those double quotes, you'll see that the result is just a question mark because it doesn't understand why you're using this global reserved word instead of a field name. So that's what's going on there. So there's a list of those reserved words in the documentation. If you go to the product documentation and then the ODBC and JDBC guide, there's a list of those reserved words at the end of that document. Also with container fields, I've got a container field in my contacts table. And you can't get the actual container data if it contains an image, for instance, or a binary data, but you can get the name of the file that was inserted in that container field. So that may be useful in some situations. Container fields can also contain text, and you can get that text out of the container field if that's what it contains. So here's an example where the container field has a few paragraphs of text in it, and we're getting the result. Now, you cannot, with the ExecutesSQL function, you cannot use the container field to actually do in the where clause to look for a specific string in that container field as text. You'll just get a question mark out of that. You won't get a result. Let me say just a little bit about data types and type mismatches here, because it's important to note that the ID field is a number field. And if we compare a number field to a text constant, then FileMaker doesn't know what to do with that in the context of the ExecutesSQL function. So it's important that your data types match. So if we remove these single quotes, then that query will work. But where we have the data type mismatch, we just get an error. Here's another example that is just showing the syntax that you use for a date constant. There are a couple of different syntaxes that you can use. If you use this date syntax right here, using the date keyword and then the year, month, day format enclosed in single quotes, that's going to work not just with the ExecutesSQL function, but it's also going to work when you're using ODBC or JDBC with FileMaker. So that's a format that works consistently across the different ways that you can use SQL with FileMaker. With the ExecutesSQL function, you can also use a format like this, which works fine with the ExecutesSQL function, but this syntax does not work if you're doing this through ODBC or JDBC. So that's something to keep in mind as you're working with these SQL queries. Something else to keep in mind is that when you have a text field that is empty, you can't directly compare that to an empty string. So you have to use an operator called isNull, and that will return the results where the city field is blank. So if we changed this to say equals and then a pair of empty quotes, we don't get any results. There are no results that match that. So we use the isNull keyword, and that'll work just fine. Likewise with date fields and number fields, you may need to use isNull as well if you're looking for blank matches. There's also a keyword or an operator that is not null, and that will give you the list of results that have a value in the city field. Okay, so let's go ahead and let's look at some other examples here of ways that you can use ExecutesSQL. So here in my states table, a layout based on the states table, I've got a chart that is using some values from the states record that we're currently on. So as we flip through records here, we get an updated chart that shows the contacts from that state and a breakdown by city. So let's look at how that chart is put together. So there are three calculations that make up this pie chart, and it's important to note that your data source when you're doing this type of chart should be current records so that you're using delimited data. So in the title for the chart, we're going to specify a calculation, and we're concatenating together the state along with the text contacts and an opening parenthesis, and then we're using the ExecutesSQL function with a simple query that says select the count of records from the contacts table where the state equals a question mark, and in this case we're passing in as a parameter the abbreviation for the state. And the result of that looks like this. So in this case, when we're on the Arizona record, we get Arizona contacts and then 25, which is the total number of contacts within that state. So let's look at the category labels calculation. This looks very similar. So in this case, we're just selecting the city from contacts where the state equals question mark, and then we're grouping those by city. So we're getting a list of city names for everyone in the state for the state's abbreviation value for the record that we're on in the states table. So let me, in case that's not clear, let me copy that calculation, and I'm going to close this and open up the data viewer. And let's just add this into a data viewer and see what we get. So there you can see that the result of this ExecutesSQL function is a list of the cities in the state of Arizona. So this is exactly what the chart is using so that it knows how to slice out the pieces of our pie. So let's go back in here and take a quick look at the slice data. And this looks very similar. Instead of showing the city, we're actually getting a count of the contacts and grouping those by city. So it's the same query, it's just a different field that we're returning that gives us a set of numbers for those cities. So let me show another example here. So this chart is very similar. It's constructed in almost the same way, except that in this case we're on a layout that is using the SQL table as its context. So the way that I set this chart up was to hard code the state as part of the query. And what that allows me to do essentially is take this chart object and place it on any layout in my solution, and it's going to work exactly the same way. So it's no longer context dependent like the other chart was, because the other chart used values from the current record to know which records to retrieve from the contacts table. In this case, the chart could be placed anywhere, and it will work exactly the same. That's really powerful when you're constructing dashboards, displaying multiple charts on a layout where you may not necessarily have relationships defined that would give you access to that related data. Building the chart with the ExecutesSQL function gives you lots of options there. Let's look at another simple example with a bubble chart that's kind of doing the same thing. But in this case, we're using some additional ExecutesSQL functions, and in this case we're querying those meta tables, the FileMaker tables and FileMaker fields meta tables, to get information about the tables in our solution. So along the horizontal axis here, we have the number of fields that are part of that table. So each bubble represents a table in our current database, and then the horizontal axis shows the number of fields within that table, and then the vertical axis shows the record count within that table. So I'm using a combination here of ExecutesSQL and some custom functions that allow us to get that information in a nice, clean way. So let's just take a quick look at a couple of those calculations. So here's an example where I've got a custom function called getRecordCount, and using that around an ExecutesSQL function to get a list of base table names from FileMaker tables, and we're ordering those by base table name. So using a combination of custom functions and the ExecutesSQL function is really powerful. It gives us lots of options to work with our data. So this is a bit of a contrived example, but it's kind of a neat way to explore what you can do with the various options within a bubble chart. All right, here's another example that instead of displaying records necessarily, I wanted to show an example of how you can take the results of an ExecutesSQL function and use those results as part of a script. So in this case, I've got a button that is defined to perform the find contacts script, and that script is expecting to receive as a parameter a list of IDs. And so we're passing as a parameter the result of an ExecutesSQL function that is simply getting a list of IDs where the first name equals the last name. Now, if you think about it, this is something that's kind of difficult to do in regular FileMaker without using ExecutesSQL, because in find mode, you can't easily compare one field to another. And so this gives us that ability to quickly do that. Otherwise, you could certainly do this in FileMaker by defining a calculation field or using scripting and looping through a set of records. But this is a quick way to get a set of results where you're comparing fields to each other. So let's just run that, and we'll see that we've got two records in our contacts table where the first name and the last name are equal. So that's an example of how to take the results of an ExecutesSQL function and pass those to a script and have some action occur on a set of records that were the result of an ExecutesSQL function, because the function does not directly impact the found set of records in the current window, and likewise, it's not. There's nothing you can do directly from the ExecutesSQL function to get data from the current found set unless you specifically build that as part of your calculation function. So I've got another script that kind of goes the other way. It takes the found set of records and allows us to do something with the ExecutesSQL function with the found set of records. So let me just demo this, and then I'll show you what it looks like. So if I choose this script, it's going to calculate an average age for the found set of records. So the average age for these two contacts is 63 years. So if we change the found set to find all records and then run that again, we'll get the average age is 49 years. And so let's take a quick look at that script. So essentially what we're doing is we're setting a variable called average days, and the value that we're using for that is an ExecutesSQL function that does a query that uses the average function to calculate the difference between the current date and the birth date for the current record. And this cur date is a built-in function in SQL that always returns the current date. So we're building that average on the fly. Even though we don't have an age calculated for these contact records, we can just build that on the fly. So what we're using as the criteria for choosing which records to include here, we're using a where clause with the ID in, like we saw some examples of earlier, but we're taking the found list of contacts, and this found list is a custom function that uses getInth record to build a list of the contact IDs for the current found set. So we're taking that list and substituting the carriage return with a comma. So that builds inside the set of parentheses, it builds a comma-separated list of IDs. And those are compared to the ID value, and the result of that gives us the average age for everyone in that found set. And then we simply have a show custom dialog script step that shows the result of that and calculates the age in years from the age in days. All right, the next example I have is using web viewers. So I've actually got two web viewers on this layout, and I want to show you how those are set up. We've got one up here that is showing a count of the records that match our SQL query, and another one that is showing a table with those values. So let's take a look at the first one here. And we're using a data URL here and calculating the number of contacts in the state of Missouri, and using that count down here in just some boilerplate HTML to display the word count and then the number of contacts that we had from this query. So this is really useful. You can take this and place it on any layout, and it's going to return the same result. You don't have to be concerned about the context of that like you would with a field. So the second web viewer that we have here works kind of the same way. We're using kind of that example that we looked at earlier that's taking the HTML tags and wrapping those around the field values. And then we're taking the result of that, so we're building that into a variable called table rows. And then we've got a little more HTML down here just to style things with some CSS. But then the result down here, we're just including the table rows variable as part of the content for this table. And that gives us just a nice HTML table. We can shrink this down, and that's nicely scrollable inside that layout. So there's a lot you can do with that to work inside of a web viewer. Lots of creative things you could do there. So let me talk just briefly about SQL injection attacks. And there's this is something you don't have to worry too much about inside of the ExecutesSQL function because of a handful of reasons. One is that we only the select SQL function or command is supported, so it's not possible to alter data. You can't insert, update, or delete. So there are limited things you could do with an SQL injection. Also, we don't support a semicolon to allow multiple commands to be executed inside of an ExecutesSQL function. So that takes away that danger as well. And also, the end-of-line comments, the two dashes together, are not supported with ExecutesSQL. So the combination of those makes it unlikely that anyone could do anything damaging with an SQL injection attack. But essentially what happens with an SQL injection is that you're accepting some information or data from a user, let's say through a web form, and you're expecting them to enter something like their first name, like Robert. But instead, the user, who's being kind of mischievous perhaps, enters some additional SQL in there in such a way that if you actually calculate that in as part of your SQL query, it will do something unintended. Like in this case, it's going to drop the table called students. So that's something to be aware of, and it's one of the things that using those optional arguments allows us to work around. So let me just show a quick demo of how that might work, I've got a script here with a couple of dialogues. And so we're prompting the user for a contact ID, and we're expecting them to put in something like a single number value. So if we do that, then we're taking that value and concatenating it with the rest of this query. So select the birth date from contacts where the ID equals 5, and we get a birth date just like we would expect. So that works fine whether we're calculating the SQL query like this or not. The other way to do this is to use that question mark syntax where we say select birth date from contacts where ID equals question mark, and then we pass in the parameter with the user's input. And this is a much safer way to go about things because we'll get essentially FileMaker is going to handle escaping this or casting this to the correct type so that we get the match that we expect here and don't get some unexpected results. So let me show another example here. I'm going to run this one more time, and instead of putting 5 in, I'm going to show 5 or ID is not null. So when we're calculating a static query like this, it literally puts in the text that we typed in, so where ID equals 5, where ID is not null, and the result of that is the birth date of everyone in our contacts table. So obviously you're not going to write a feature that asks the user to enter an ID number, but maybe you would ask a user to enter an invoice number or a username or some other value like that, and you are always expecting a single result or no results. And here's an example where you might get more results than you expected to, and that might allow the user to have access to some data that, that you wouldn't expect them to be able to get to easily. So if you had used the parameter or the optional argument here, then even though the parameter says 5 or ID is not null, this gets casted to a number. And so the result is essentially just the date of the record with the ID 5. Okay, so let's take one more look at the arguments here. And here's some examples. These 4 ExecutesSQL functions work exactly the same way. They give the same result. So we're selecting the last name from contacts where the first name is in this list of values, and we're so in this first example we're hard coding these 3 names and putting single quotes around them. So these are just text constants. The second example here replaces those with the question marks and then passing those names in as those optional arguments. So you might be looking at this and thinking, well, I like that first one better. It's shorter. It's a little bit simpler. It doesn't have this this strange syntax here. But let's look at another example where we're actually, instead of hard coding these values, we're passing those in from a variable, or perhaps it could be from a field. And so in this case, when we go to hard code it, we still have to have those single quotes around the text values. So we have to have a single quote here. Let me blow this up just a little bit so you can see what's going on. So we've got a single quote here and then a double quote to close this string, and then an ampersand and then the name of the variable, and then another ampersand, and then we have to have a single quote and a comma. So that syntax gets a little bit tedious. Where we're using the question marks here, then we can just pass in the values and FileMaker takes care of the quoting for us. So in some cases that can be significantly simpler. The query is shorter and it's easier to understand and a little easier to avoid mistakes. All right, so those are those demos. Let me switch back to PowerPoint. I've got just a few more slides here, a couple of things to mention. If you're going to have a string of text that has a single quote in it, you have to escape that with a second single quote. So that may be another argument in favor of using the parameter approach because FileMaker will take care of escaping that for you. I also wanted to mention that date, time, and number fields, you can use the null keyword to represent a blank value. And we also mentioned this briefly, but if you have field or table names that that aren't just simple words that that match a certain set of criteria, you have to put double quotes around those. So One class of those that you have to put quotes around are reserved words. And here's some examples: first, count, session, and user. So those are things that you might see commonly as table or field names, and those would certainly have to be enclosed in double quotes, or you'll get an error with ExecutesSQL. Likewise, if you have a space in your field name or a table name, you'll have to put quotes around it. If the first character is not alphabetic, you need to have quotes around it. And if any character in the field or table name is not an A through Z or a number or an underscore, then you must have quotes around it. So in this case, we've got just a dash in there that has to have a quote around it. There are some examples here of constants, so I just wanted to share those with you. It's an example of the formats you can use for dates, times, timestamps. There are other syntaxes that work, but I would encourage you to think about using these if you're going to also be using SQL through ODBC or JDBC, because this format will work in those cases as well. So a couple of summary thoughts here. ExecutesSQL is just a tool. It's another feature that we've got in FileMaker 12. The great thing about it is that it doesn't require drivers. It doesn't require DSNs. Any of that stuff that you might be used to with using SQL with FileMaker in the past. There's no plugin involved, and it works just fine with FileMaker Go. So everything I showed today works great with FileMaker Go. So you can use this throughout your solution and be comfortable that it's going to work across the FileMaker products, Go, Pro, and Server. It really helps to simplify your relationship graph, so it gives you lots of options to avoid having to add additional table occurrences and relationships to get data in the right context. And it helps with the portability and reusability of your code or objects that you've created, like web viewers, charts, things like that. You can create some really powerful interfaces for allowing user-defined reports. This works great for the virtual list technique. You can also create some interfaces that allow users to specify criteria dynamically at the time they want to generate the report that might not be possible without creating some additional relationships or table occurrences. So there's some creative and powerful things you can do with this that will really help your users. So, but also keep in mind that this, like any tool, it can be used poorly. If you use ExecutesSQL with really large tables, or if you put 12 conditional formatting calculations with ExecutesSQL in each one of them and have that on a list view, and then somebody in FileMaker Go tries to open that up over a 3G connection, it's going to perform poorly. So above all, I want you to take away that you need to be sure and test with appropriate sample data and in an environment that is similar to what your users are going to be experiencing, whether it's a WAN connection or the kinds of devices or computers they're using over the same type of network with the same kind of sample data that they're likely to use. Because the ExecutesSQL function can perform poorly if you have really large record sets. If you're using ESS tables, it still works, but it can perform very slowly. It's not like the SQL query gets passed through to the back end for an ESS data source. It's all done inside of FileMaker. So we have to get the data from that ESS source, and then the SQL query from our ExecutesSQL function is applied locally within FileMaker to get the result. So that can perform slowly, so watch out for that. A couple of resources I want you to be aware of. First of all, in the FileMaker documentation, we've got the ODBC and JDBC guide that's got a chapter that talks about all of the syntax that's available for the select queries. It also covers insert, update, and delete, and some DDL commands for creating tables and creating fields and that sort of thing as well, but those really only apply to ODBC and JDBC. So just look at the chapter that includes information about selecting data and the various clauses and functions you can use for that, and there's some good information in there. Also, the list of reserved words for SQL are in there as well. Seed Code has just released this week a new tool called SQL Explorer. It's free. I'd encourage you to download that and check it out. It allows you to kind of explore what you can do with SQL and the ExecutesSQL function within FileMaker, and it uses kind of native FileMaker language to guide you through that process. Similarly, Eden Morris has a tool called SQL Builder, and there's a discussion about that and links to that tool on FM Forums if you follow that link. So I encourage you to check that out as well. And Kevin Frank has a great blog at FileMakerHacks.com where he's got several blog posts about using SQL with FileMaker. I'd encourage you to check that out as well. There's a few other resources there, just general links to things that might be worth checking out. There are several ways to stay in touch with Skeleton Key, and I'd encourage you to email us or connect with us in one of these other ways. But at this point, let me move on to questions. Jason, do we have some questions?
We have a lot of questions, Greg. Thank you all, and I'm going to start by addressing a couple that come up over and over again. This recording of this session will be available. Recording of previous sessions are available. Point a browser at FileMakerAcademy.com to find those and the recording of this session along with the sample files that Greg's going to provide. So we've only got a few minutes and we have a ton of questions, so we'll not get through them all. Please continue to ask and we'll catch up with you afterwards. So I'm going to start at the top and run through as many as we can, Greg.
Okay.
Can you select data from an external FileMaker file? Example, if you're using the separation model, does the table occurrence need to exist in the current file even if it's not related?
So the SQL that you create references table occurrences, not the base table name. So anything that shows up in the graph in the current database, whether that table lives in the current database or a separate database, it doesn't matter. As long as the TO occurs within the relationships graph for the current file, you'll have access to it through the ExecutesSQL function.
A couple of questions touch on performance. So I'm going to ask very broadly, how fast is ExecutesSQL on very large data sets?
So just in general, you can certainly create queries. Even with a small data set, you can create a query that performs poorly. And with a large data set, if the query is simple and just referencing a specific record, you can get the data back quickly. So this is not a magic bullet for performance or improving performance. There are certainly things you have to think about as you're building your queries. And in general, I would say that most things are not going to perform better with the ExecutesSQL function than they would with other native ways that you could do it in FileMaker. So above all, you just have to test and see how things work for you. Use this if you're going to have over so many records. I don't have anything like that to share. But one thing to keep in mind if you're doing dashboard solutions or things like that is that you can easily use some like a server-side scripted process to summarize and get data from various tables and put that into tables that you use just for reporting. So the ExecutesSQL function can be really useful like for a dashboard of displaying information that is like pre-summarized in tables specifically for that purpose from some other source. So that's something to think about as well.
So Greg, in the ExecutesSQL script, explain how people can put a description text to document steps as they go. Is there a good way to do that?
So you can include comments within an SQL query. So within the SQL query part of the ExecutesSQL function, you can include comments within a slash asterisk and then the comment and then an asterisk slash, and those comments will be ignored. Similarly, like I showed in several of the examples, you can use white space, you can use carriage returns within your query, and it doesn't affect the result. So I'd encourage you to do that as well to keep things a little cleaner.
What sort order is data returned in?
So by default, you're going to get the results in creation order, just like you would in FileMaker. But there is an order by clause that you can use with any query that allows you to specify the fields that are that the results should be sorted by. So you say order by and then the name of the field, and you can have an optional list of fields like first name, comma, last name, and it will sort in that order. There's also a descending keyword, or a DESC keyword, that allows you to do a descending sort instead of an ascending sort.
So we have time for one more question. Greg, is it possible to pass SQL results to value lists?
No, not directly, not in any way that I know of. You would have to get the results of the SQL query into a table somehow to use those in a value list.
So we have a lot of questions left. We really appreciate all the questions, and look forward to following up with all you folks. In the interest of time, though, we need to let you go. Please come join us again on May 15th for webinar number 11 in the series. It's called Script Trigger Enhancements. We're excited to see it, and hope to see you there. Thank you again.
Thanks, everyone.